Hello there, I am Chandrima Banerjee, an aspirant in research and academia. In today's video, I will share my academic background, experience and eligibility. I am a doctorate in physics. My research area is optospintronics, which is a highly interdisciplinary topic involving the knowledge of physics, electrical engineering and material science. The works in spintronics are motivated by the drive to push the computation technology from a scalar or electron charge based to a vector, namely spin based one. In present electronics technology, we use electron charge, which is a scalar quantity, and the computation is performed by the presence and absence of the electron charge controlled by voltage. Such technology is suffering from heat consumption and limitations on further downscaling. With spin-based computing, we can use the electron spin direction or even the propagation of magnetic perturbation in the form of spin waves. So we have more parameters, so more freedom. For example, we can write the data bit by switching the magnetization direction. In fact, the magnetic memory has already entered the present hard disk drive technology. Also, magnetic RAM memory is on its way to be commercialized. We can as well use the properties of spin waves such as amplitude modulation of spin waves, their interference or their propagation symmetry to perform logic operations. Here I will give a brief summary of my academic career. As I mentioned earlier, my research area deals with the interdisciplinary topic of optics and spintronics. In my academic career, I have gained experience with different optical techniques to probe various facets of dynamic magnetic properties. I finished my post-graduation from IIT Delhi in 2012. Then I joined SN Bose National Center for Basic Sciences, India, to pursue my doctoral research under the supervision of Professor Anjan Burman. My fellowship was awarded by CSIR NET. My thesis title was Experimental Study of Spin Waves in Magnetic Thin Films and Nanostructures. My research works were published in different journals including Physical Review Applied, Physical Review B, Scientific Reports, RSC Advances, Journal of Applied Physics, Material Science and Engineering B, etc. During PhD, I used Brillouin light scattering technique to study the spin wave properties, its tunability, and the band structure in different magnetic nanostructures, including exchange spring system, magnetic layered and pattern structure, pattern domain system, etc. I also developed programming code to numerically calculate the magnonic band structure and to spatially map the spin wave propagation in magnonic device. After PhD, I joined Trinity College Dublin, Ireland for postdoctoral research in the group of Professor J.M.D. Coe. My fellowship was awarded by Irish Research Council, Government of Ireland. There I worked in the research area of ultrafast magnetism, where I studied the interaction of ultrashort optical pulses with the magnetization in the sub-picosecond to few picoseconds time scale. My research works were published in Nature Communications, Physical Review Letters, Physical Review Research, etc. In Trinity College, I built a time-resolved magneto-optical pump probe spectroscopy with double pump excitation scheme and also wrote programming code to simulate the transient magnetization loss due to ultrashort optical pulse. While we studied the interaction of intense optical pulses with a ferrimagnet, we observed an interesting phenomena. That is, the magnetization of the system could be flipped with a single optical pulse. So whatever the initial magnetization direction is, upon the action of each single pulse, the magnetization would switch. So a toggle switching was observed. This toggle switching is very important because it shows a new route to write magnetic data bits which is compatible with optical fiber-based communications. From the measurement of time-resolved dynamics, we found this switching is the fastest of all optical switching reported so far. Presently, I am working in Technion, Israel, in the group of Professor Oren Cohen. My fellowship is awarded by the prestigious Fellowship of Excellence Fellowship for International Postdoctoral Researchers given by Israel Academy of Science and Humanities. My present research area belongs to soft X-ray spectroscopy. In particular, it is time-resolved X-ray magnetic circular dichroism spectroscopy. Here, the soft X-rays are generated from infrared laser beam using high harmonic generation process. This process gives a train of attosecond pulses, the Fourier transform of which gives a broad spectrum of soft X-rays, which corresponds to the X-ray absorption peaks of different magnetic materials. Hence, we get a better spatial as well as a time resolution down to attosecond regime. Then using X-ray magnetic circular dichroism spectroscopy, we can get in-depth information about light-spin interaction in a complex magnetic system. So here is the list of my publications. So far I have authored in 16 peer-reviewed journal publication, 1 conference publication and 1 book chapter. Among them, 8 articles are in first authorship. For more information on my research work and publication, please visit my Google Scholar page. I have also received a few fellowships and awards. Before PhD, I cleared CSIR NET exam with a good All India ranking. During postdoc in Trinity College, I received Irish Research Council postdoctoral fellowship given by Government of Ireland. I have received the postdoctoral fellowship under Excellence Fellowship Program for International Postdoctoral Researchers, Israel. I have been recently invited to deliver a talk in the International Colloquium on Magnetic Films and Surfaces 2012 to be held in Okinawa, Japan in July this year. I have received Best Poster awards in different international and national conferences including IEEE Magnetic Summer School. Also, I cleared GATE and JAM exams. I was selected to receive travel grant to attend international conference from DST ACRB. Now I come to my future plans in research and academia. As for research, I wish to continue with optospintronics. The research in spintronics is rapidly growing not only by the development of new materials but also with emerging new phenomena with both scientific and technological importance. I wish to build a time-resolved magneto-optic pump probe spectroscopy, which latter I want to extend to soft X-ray spectroscopy setup. I also wish to build a setup for Brillouin light scattering experiment where spin wave propagation can be measured and imaged. For time-resolved soft X-ray spectroscopy, I am interested in the measurement of antiferromagnetically coupled systems. In antiferromagnetic systems, there are two spin components which cancel each other. Therefore, such system does not interact with outside magnetic field. But upon optical excitation, they undergo intricate interaction with each other which cannot be measured by any other means. I am also interested in studying how the spins interact with each other in presence of various spin ordering such as chiral magnetic structure, spring-like structure, etc. I also want to build a micro-focused Brillouin light scattering imaging setup. Here, using a microscope objective, we can spatially map the propagation of spin waves of different frequencies in a real magnonic device, which provides a handle to control it. Like any other wave, spin wave group velocity follow the isofrequency contour inside a medium. Because of the dipole interaction is anisotropic, we can see from the simulation result that when the spin wave excitation is launched inside the medium, it does not follow a circular wave front. Rather, it follows a V-shaped wavefront. I wish to study the tunability of this propagation behavior, which will be potentially useful in magnonic logic devices. Now I come to my teaching interest. Based on the subject knowledge of my research topic, I wish to introduce a course which is Introduction to Optospintronics. Here I want to start with the basic concepts of magnetism such as magnetic domain, magnetic anisotropy, exchange interaction, spin wave, etc. Then I wish to move on to significance and advantages of optical techniques. Then various magneto-optical interactions like magneto-optical Kerr effect, magnetic circular dichroism, magneto-optical scattering will be covered. Magneto-optical spectroscopy, magneto-optic imaging follows. Then interaction of spins with ultrashort light pulses. Then where I will discuss about timescales of different magnetic phenomena starting from nanosecond to attosecond regime. Then I will introduce the ultra-fast magneto-optics and finish with it. Apart from that, I can also teach these courses such as Introduction to Electrical and Electronic Circuits, Analog Circuits, Photonic System Engineering, Nanomagnetism, Spintronics, Fiber Optic Communication, Electrical and Electronics Laboratory courses. I am able to teach few other subjects as well, such as wave and optics, electricity and magnetism, leisure physics, solid state physics, optical laboratory courses. So with this, I end this video. Thank you very much for listening.